Hi everyone, I welcome for the presentation on layout construction using stick diagram of the MOS circuits. In my earlier presentation, I gave an explanation on how to construct the stick diagram using the MOS circuit. So in this presentation, I'll be explaining how to construct the layout using the stick diagram. Before we actually go into the construction of the layout using the stick diagram, let us first understand some of the design rules pertaining to the layout construction. So what are design rules? Design rules are nothing but the set of guidelines which specify the minimum dimension and spacing that are allowed in layout construction. So layout is nothing but it describes the actual layers and the geometry on the silicon substrate in order to implement any of our digital circuits. So our design rules is based on the lambda based design rules, and also one more type, what we call it as micron based design rule. So in this presentation I'll be discussing only the lambda based design rules. Lambda based design rules are proposed by Mead and Conway. These are the two persons who have proposed this lambda based design rules. In this lambda based design rule, lambda is the parameter which is also called as the scaling factor or the feature size, and all the mask patterns are expressed as a multiple of this parameter lambda. Lambda is usually half of the minimum transistor channel length, which is also called as feature size. So in this picture, you can see what are the design rules that are applicable for our wires, that is especially diffusion, polysilicon and metal. So the minimum width of N diffusion or P diffusion should be 2 lambda, and the separation between the diffusion and the polysilicon will be 1 lambda. Width of the polysilicon is 2 lambda, and the separation between two polysilicon layers should be 2 lambda. Similarly, the separation between two diffusion layers is 3 lambda. Coming to the metal 1 width should be of 3 lambda, metal 2 width should be of 4 lambda. The separation between metal 1 and metal 2 is 3 lambda. So these are some of the rules one has to follow in order to construct our layout using the stick diagram. So when there is no separation that is specified, say for example metal is a layer which can run on any other layer, which can overlap or run on any other layer. So in that case, we are not going to specify any separation distance in terms of lambda. So coming to the next design rule based on the transistor for NMOS, PMOS and CMOS, one can see for NMOS enhancement and PMOS enhancement, because their width are 2 lambda both for polysilicon and N diffusion as well as P diffusion. So for NMOS it is represented as 2 lambda cross 2 lambda. Similarly for PMOS it is 2 lambda cross 2 lambda. So coming to the depletion mode NMOS transistor, the width of the polysilicon and the diffusion remains same as 2 lambda, whereas we need to have an extra layer, what we call it as implant, which is of dimension 6 lambda cross 6 lambda. And you can see the separation from the contact cut to the transistor, it should be 2 lambda minimum of 2 lambda. It can be more than that, but it should not be less than 2 lambda. Also you can see on the bottom, the separation between the implant and the next another transistor, it should be 2 lambda of a minimum separation, which can be more than that, but minimum should be of 2 lambda. So again, these are some of the rules one has to follow as a designer in order to construct the layout of the given circuit diagram or stick diagram. And polysilicon it should extend minimum of 2 lambda beyond the diffusion boundaries. This is one more rule. in which one has to understand and adapt while constructing the layout diagram. So the first circuit or the stick diagram which I'm going to consider here is the NMOS inverter. You can see on the left hand side we have the stick diagram for the NMOS inverter which we had discussed in the previous session, and one can observe there the the length to width ratio is 4:1 for the depletion mode MOSFET, and length to width ratio for enhancement mode NMOS transistor is 1:1. So on the right hand side, you can see the layout construction for the NMOS inverter. The first thing which we need to know is what are the representation in terms of layout construction for metal, polysilicon, diffusion, contact cut, as well as implant. So first we need to, as we saw in the stick diagram, we need to have VDD and VSS rails. That is the first construction in our stick diagram, VDD and VSS rails. Similarly here, VDD is represented using metal 1 rail and VSS using also metal 1. And we know that the width of the metal 1 should be 3 lambda, which is represented here. And the length of the NMOS depletion mode transistor is 4 is to 1 in terms of length is to width. So this will be the length of the depletion mode